Let's discuss a question from machine design. Basically what is given is a solid shaft is welded to a flat plate. So you have a flat plate here, you have a solid shaft, and how do you weld it? You circumferentially weld it. Okay, this is so the weld in this front view, the weld will appear as a hollow, as a ring. Okay, now this is basically you're applying torque on the shaft and the entire torque falls on the weld. The interest here is to design the weld. Okay, so how much torque, I mean how much stress that this torque can set up in the weld. So we are already given with the hint that the expression for tau, the shear stress that is set up in the weld, is given as 2.83 T by pi h d square. Now just I'll explain you how to derive this because that may be important for your for later purpose. So basically this is a ring, and ring in this nomenclature of weld, if you remember the weld basic background, this is your weld size, which is your h, and we consider the minimum cross section area, which is your throat. So this is your throat, so this is your throat, and in fact let me just draw this way. This is my h, this is my throat, the minimum cross section, and this is 90. So this is 45 and h is hypotenuse, so h sine 45 is t. Now in this t, this throat length or this minimum throat area is what we consider for the shear stress. So this is my throat t and this is a ring. So if you apply the torsion equation such that the entire torque is resisted by this hollow circular cross section, T by J is tau by R. So if you apply this, you end up getting this equation. So we'll just use this because it's already given, and this is, so all the force units we'll take in Newton and the length unit in mm square. So 70 MPa will be in Newton per mm square, so we'll just directly write 70. 2.83 torque is something which we need to find out. Pi h is given as in mm, 8 mm fillet weld size, and dia is 50 mm whole square. So all the length units in mm, force unit in Newton, so torque we get it as 1.554 into 10 power 6. You just use the calculator. Newton mm, it's length and force unit, so Newton mm. So D is the answer, just direct substitution problem. Thank you.